Let's go over basic properties of log. I will start with logarithm of a product. So on the left side, we have log base a of m times n. Okay, when you have a product as log argument, m times n, we can separate this single log expression as two separate log of the same base. So what I can write this into is log base a of m plus log base a of n. I'm going to go ahead and find example problems that are using this property down on this example. And I got these about 6 or 7 examples from your ALEKS homework. What we're going to do is we're going to I think we were going both way. They may ask us to multiply the separate log arguments or write them as two separate logs using addition. So, well, remember this red rule, this logarithm of a product, and let's take a look at the first one. So when you have log base 9, the first one, log base 9 of 8, look, the argument is 8, plus log base 9 of 11. What we should focus on is that the sign in the middle is a positive. So this, what we can use is we can use the log property. All right, hold on. Let me change this to product property. I call this product property. Because same base log, both the log base 9, are connected by a plus sign in the middle. That means I can rewrite this as a single log of base 9, but the argument will be 8 times 11, 8 times 11, 88. That was our first example together. Wonder if there's another one on this. No. So that was just one example of a log of a product. Or when you have two separate logs of the same base that are adding together, we can combine them. We condense it as a single log. But for the argument, you just multiply those arguments, 8 and 11, and then we got 88. All right, how about the subtracting one? Well, if product separated into a sum, you can probably guess that when you have a division, when you have a quotient of m over n, m and n, you can write this as log base a of m minus log base a of n. So, and we'll see that whenever a term is in the bottom of the fraction, when you separate it out, it's going to have a minus sign in front of it. But m is on top of the fraction. That's why the log expression with m does not have a minus in front of it. This one is positive. So let's look at some examples that has this quotient property, okay? So B and C, and I think D too. So let's look at B first. I have log base 9 of 4 minus log base 9 of 5. What I should pay attention to is that the sign in the middle right there is a minus sign. So for the plus sign, when you have a plus in the middle, you will do the product. But when you have a minus in the middle, you will do the quotient. You will divide those arguments. So we are using quotient property. So if you divide 4 divided by 5, that will just be 4 over 5. That will just be 4 over 5 as a new log argument. Okay, how about the next one? Well, this one, we're finding the missing argument on the left side. So let's see, log base 2 of 5 minus, look, minus sign connects these two log expressions. So I'm going to go with the quotient property. What that means is 5 divided by something, 5 divided by this something gave us 5 over 9. So you can almost set up an equation if you want to. So what we get is 5 over something is 5 over 9. Well, that something must be x. That something must be 9, right? 5 divided by 9, we have to have 9 in there. to get 5 over 9 equals 5 over 9. So that one was pretty obvious, I think, because the numerator kept that number 5, the denominator should just be 9. How about the next one? I think D is another quotient one because I have log base 8 of blank. Okay, something is getting divided by, because look, the sign in the middle is subtraction. We are using the quotient property. So something divided by 5 is 15. So I'll go ahead and write that down. Something divided by 5 is equal to 15, right? And that something is this missing log argument. X divided by 5 equals 15. So how do you find that x value? Multiply both sides by 5. 15 times 5 is 75. So the original log argument must be 75. Now let's check. 75 divided by 5 is 15. And if you even want to go and type this up in the calculator, they will give you the same decimal. All right, so we looked at just one example of product property and 3 examples of quotient property. And I got, I think, 3 more on the last property called the power property. So take a look at this very last one for me. When you have, this is what I do. Whenever you have an exponent in the argument, you notice that this is log base a of m raised to the p power, right? I'll bring this down in front of it. And what you can write is p times log base a of m. So when you write your log argument as a power with an exponent, that exponent can be brought down in front of the entire log expression and becomes that number times the original log expression without that exponent. So let me go over some examples with you, okay? Example of that. If you have natural log of 5 raised to the maybe x power, you can say this is the same as that x coming down in front of it. And I usually just draw like a line coming down in front. X comes down, and we're multiplying that by natural log of 5. This will be very useful when we solve exponential and logarithmic equations later, okay? Logarithmic equations, not exponential equations. So remember this property, and I just call this power property of log. So example E, take a look at this one for me. And I'll do this. What we have is log base 8 of 32, but see if you agree with me that 32 can be written as 2 to the 5th power. Okay, 32 can be written as, note, 32 can be written as 2 to the 5th power. That is true, right? And why did I do that? I'm going to bring down that 5, that is an exponent, in front. Let me play with some colors real quick. Bring that 5 down in front of it. So you're going to write down 5 times log base 8 of 2. So that's what's happening. If you can rewrite your argument as a power, something raised to an exponent, then you can bring that exponent down in front of it. So it becomes 5 times log base 8 of 2. Okay, let me try another one. F is a little bit trickier. Okay, F is a little bit trickier. And I think G is a similar type. What I'm going to do is I'm going to rewrite this log base 7 of 1 over 4. And 1 over 4 is, and you know, many things can be 1 over 4, but what I noticed is this. Take a look at the number that's in front of this log expression on the other side. You see that negative 2 is in front of it, right? Well, that means they were able to bring down negative 2, which was an exponent. So what I'm thinking is this. We are rewriting the arguments so that it becomes x raised to the negative 2nd power, okay? And what happened was they brought this negative 2 down in front of it, right? All right, hold on, let me go ahead and draw some lines. That's what happened. They rewrote this log base 7 of 1 over 4 as something raised to the negative second power and brought down that negative 2 in front of it. That's why they have that negative 2 in front of log base 7. So what's left is x. We better find out what this base is. So let me go ahead and do the work on the side, okay? So what we got is x to the negative second power equals 1 over 4. Okay, we must rewrite this 1 over 4, this quarter, as something raised to the negative second power. Now, raising something to the negative second power is same as 1 over x squared, isn't it? Because of the negative exponent, it goes to the bottom. But now look, what must be x? X squared is equal to 4. So if you want to solve that, you will get x squared equals 4, and you may get x equals positive or negative 2, but in this case, I think only the 2 will go. Yeah, it should not be negative 2 because log argument cannot be negative, okay? In 3.3, we talked about how to find domain of a log function. And to find the domain of a log function, argument had to be greater than or equal to greater than 0, not equal to 0, but strictly greater than 0, right? So even though technically if you solve this equation, you get x equals negative 2 and positive 2. Unfortunately, negative 2 is not the solution because we're solving a log equation, and argument of a log has to be positive, and it should not be a negative or 0. So the answer is 2 here. X is 2. All right, let's try another one very similar, and this will be the last one. What we got is log base 5 of 1 over 8 equals negative 3 log base 5 of something. So what they did was they rewrote this 1 over 8. They had log base 5 x to the, now look, what number came down in front of it? Negative 3. So the exponent must be negative 3, right? The exponent must be negative 3. That's why this negative 3 came down in front of that log expression. So what I need to do is I need to set up an equation first. I'm going to say that x to the negative third power is equal to 1 over 8. Okay? X to the negative third power equals 1 over 8. Well, that means 1 over x to the third power is equal to 1 over 8, which means x to the third power must be equal to 8. Because both the numerators are 1, the denominator must also be equal to each other. So x cubed equals 8. If you solve this by taking cube root of both sides, you will get x equals 2. So, and it doesn't get negative 2 this time because cube root of 3 is only positive 2. So the answer is automatically 2 here, okay? So if you had log base 5 of 2 to the negative third power, you can bring down this exponent in front of it, and you will have negative 3 times log base 5 of 2, okay? So the real challenging part of the last 2 example was just remembering about these properties of negative exponents, okay? And how to rewrite 1 over 4 or 1 over 8 as x to the negative or 2 to the negative second power or 2 to the third power, okay? So that's it for this video. I will come back and show you another property called the change of base for logarithms.